Yes.
Fourth topic is transformation. And this transformation is related to graphs, sketches. Okay, let's start with one basic example. Sketch and then transform. If I say we have y-axis, x-axis, and you are given with the line y is equals to 2x. Do you accept this sketch as true? Y equals 2x. General form is y equals mx plus c, where m is the gradient and c is the y-intercept. So when it is y equals 2x, 2 is gradient and there's no y-intercept, that means it is 0. And if I ask you to draw the line y is equals to 2x plus 2, would you agree this line would look like this, parallel to the previous one, but now it intersects at 2? Suppose the question tells you to draw y is equals to 2x minus 3. So it will still be parallel to the previous lines, but now it intersects at minus 3. Any disagreement? Our actual question and syllabus is on curves. So first we are discussing linear. So we don't have to go in detailed calculations. Graph A, graph B, graph C. Question, the wording of question will be, what happens to line A when it moves to line B? Or it would say, explain the transformation from A to B. From A to B. If you see, A is the line in red, B is the line in green. So may I give this answer? From A to B, I can say it is a translation of x0, y1. Do you know what translation is?
Yes.
In other words, we can say the line has moved 1 unit. Sorry, this was 2. X0, y2. The line has moved 2 units in vertical axis, in positive vertical axis. So in technical way, we tell them that it is a translation of 0, 2. Okay, comparing this with this new question, if I say that we have a graph which is a curve and the turning point is x2, y1. And then we have a new curve whose turning point is x5, y2. And the equation is not given. The equation is not given. Again, from A to B. The question says, explain the transformation Explain the transformation from A to B. May I say it moved 3 units in x-axis and it moved 1 unit in positive y-axis. It is a translation of 3, 1. Any disagreement? From positive 2 in x-axis, the curve has moved to 5. So it has moved 3 units. Then from positive 1 in y-axis, it has moved to positive 2 in y-axis. It is a movement of 1 step upwards. So the translation is 3, 1 for every point. Although equation is not given, we can still comment what happened to this curve. Straight line and then the curve. It's got stuck. Let me open that again. This was x2, y1 and x5, y2, A, B. From A to B, it is a translation of vector 3, 1. Clear? If it is clear only, then I'll move to next step, which would be generic forms. And you'll have to convert the equations into completing square form. Y is equals to ax minus h whole square plus k. Remember this form? If a is positive, it is a smiley face. If a is negative, it is a sad face. Turning point. Coordinates of turning point are h, comma, k. Do not forget the sign of h has been changed from negative to positive. Whatever the number would be, will change the sign. So turning point is this. So now what actually happens? When you increase the value of h, the curve moves to left. When you decrease the value of h, the curve moves to right. First part of the discussion, memorize it a little. Second part, I'll clear the concept with examples. This is what happens to the curve when we adjust the value of h. For k, when the value of k increases, curve moves up. When the value of k decreases, curve moves down. H and k, what happens when we adjust the value of a? When a increases, the curve squeezes. When a decreases, curve expands. We have 3 constants, a, h, and k. What happens to the curve when we change these values? A increases, the curve squeezes. A decreases, the curve expands. Increasing K would take the curve upwards. Decreasing K would take the curve downwards. Increasing H would move it to left. And decreasing H will move it to right. Coming to examples, I will first change the values of H only. Y is equals to X minus 3 whole square plus 4. Yes, Mark.
So when you say increase and decrease the value of h, it says the curve moves to the right. Does the turning point only move, or does the entire curve move?
The entire curve. If you look at this example in blue and red, it moved from 2 to 5. So basically the value of H was decreased and the curve moved towards right. And it moved from 1 to 2. That means the value of K was increased. So the curve moved upwards. I'll show you with numbers. Y is equals to X minus 3 whole square plus 4. So I know that the turning point of this curve is X3 and Y4. If I need to sketch this, and it is a smiley face because value of A is plus 1. So X3 and Y4, suppose we have this over here. So this will be my curve, 3, 4. New equation. Y is equals to X minus 4 whole square plus 4. What did I do? What is the difference between these two equations?
The turning point has been decreased.
The turning point has been changed. The value of H is been decreased from minus 3 to minus 4. Decreasing the value of H. Can I say the turning point now is 4, 4? Because we know, look at this point, because we know that the sign of H changes. The sign of X coordinate changes. So this becomes from negative 4 to positive 4. That would mean it is moving towards right hand side in the horizontal direction 4, 4. So can you see the transformation even without sketching the graphs? From A to B, the graph actually moved towards left, and I can say translation is X1 and Y0. Do you agree with these 3 points? Equations, translation, and graph. I will take it slow. These questions are more of observation and less solving. So I need your consent before we move on. First equation A, X minus 3 whole square plus 4. We know that the turning point is 3, 4. New equation, X minus 4 whole square plus 4. The only change is value of H. For the time being, we will definitely adjust all values and see what happens. So from 3 to 4, value of H decreases, but the graph moves towards the right hand side by 1 unit. So if I change it to Y is equals to X minus 7 whole square plus 4, name it equation C, compare it with the first equation. Without drawing, what can I say? Value of K is same, X is same, square is same, A is same, only H is changing. Only H is changing. If I compare the first and the last one, A and C, what is the change? Value changes from 3 to
7.
3
If you
to
put
7. The turning point will be
7, 4.
7, 4. So if I need to sketch this, I will move towards right hand side, and this will be 7, 4. G. Is it clear?
Yes, sir.
Yeah.
Now, is the concept clear that decreasing the value of h, why the curve is moving to right hand side? So let's increase it once.
Yes.
D. Y is equals to x minus 2 whole squared plus 4. The turning point will be 2, 4. So original equation was in black. Now the turning point is x2 and y4. Do we agree to this? 2, 4. See, increasing the value from -3 to -2, increasing the value of h, moved the curve to left hand side. There is no restriction in the question to answer in technical form or as theory. For example, I'm comparing A and D. I will say the curve has moved towards left hand side by 1 unit. Or I can say that it is a translation of -1, 0. Both are acceptable. Is it clear? Comparing
Yes.
with the first one, translation vector for C. Comparing C, it moves 4 units in horizontal direction and 0 units in y direction. So we just saw what happens when we increase or decrease the value of h. Now let's try k. Y is equals to x minus 3 whole square plus 4. And the graph will look like this, 3, 4. New equation, y is equals to x minus 3 whole square plus 7. And the graph will look like this, x3, y7. Is it okay? No change in x-axis, only y-axis changed. So the translation vector will be x0, y3. Translation of 0, 3. Yeah, is quite silent. Are you getting it?
Yeah, I understand it.
Okay. Mohammed,
I understand.
so we have adjusted the value of k. Let's try by decreasing the value. Y equals x minus 3 whole square minus 2. So now I know that the turning point is x3 and y minus 2. And it is a smiley face. And it will cut from the positive y-axis. Why from the positive y-axis? I just checked, substituting x with 0. So minus 3 square is 9, 9 minus 2 is 7. So it cuts from the positive axis. So what is the translation vector? Comparing with the original equation, the translation vector is -6 and 0. From 4 to -2, change is 6 units, but it is moving downwards. So -6 and 0. H and K. Is it acceptable? We can take a break if you want. We can take a pause.
I have a question.
Yes.
So where you said y equals x minus 3 squared minus 2, when that, where did you get, so you said -6. Which two equations are you comparing to get
-6
-6?
compared first equation with the last one, A, B, C. We're comparing the first and last.
Okay.
This
Oh.
was A to B. This was A to C.
Sir, is the y-axis going from 4 to -2? Shouldn't it be 0, -6? Or
Right, thank you. You're right. This is 0, -6. There's no change in X and 6 units decreased in Y-axis. Thank you, Mohammed. Now let's do it both ways. Y is equals to X minus 3 whole square plus 4, first equation. And if I do not draw, Y is equals to X minus 5 whole square plus 9. From A to B. A to B. May I say it is a translation? Okay. Is the graph moving towards left or right? Compare the X. Value
is
of
it
H
moving
is,
right?
it is moving right. Value of H is decreasing. So the graph is moving towards right. By how many units? From 3 to 5?
2 units.
It is 2 units. And what happens when it moves from 4 to 9?
It's 5 units up.
5 units up. So it is a translation of 2, 5. So you don't have to sketch the graph always. Sketching is just for understanding. It is not the requirement of question. So if we sketch y is equals to x minus 3 whole square, I know that the turning point is 3, 4, and the turning point in second equation is 5, 9. So x3, y4, let me say this is the first graph. And let's use the same color for easy comparison. And second is x5, y9. 5, 9 and 3, 4. So the entire graph has moved 2 units to left and 5 units upwards. So it is a translation of 2, 5. Till now, we've dealt with H and K and did nothing with A till now. Is H and K clear?
Yes.
Before we move on, do you remember what stretch was? In transformation, we had rotation, reflection, enlargement, translation. Do you remember or do you know what stretching is or shearing is? Have you studied that? Stretch and shear.
No.
Okay. Just for the sake of understanding.
Stretching of graphs, right?
Stretching of graphs, yes. If we have this rubber material rectangular shape and you pull this green side towards right and the new shape looks like this, it has been stretched. I can say that if the first length was 1 unit, new length is 1.5 times that of the previous length. If I draw it like this, so in green, I can say it is twice the original length. For green, I can say the scale factor is 2. For red, I can say the scale factor is 1.5 times. For blue, I can say the scale factor is 1. Scale factor 1 means it has not been stretched. It is of the original size. Scale factor 2 means it has been stretched to such an extent that the new size is twice the size of original one. If we have to draw for scale factor 3, so it has to be stretched to a limit that it is 3 times the original size. Getting it?
Yes.
So if we compare these two graphs, number 1 and graph number 2. So this is not a stretch from black to blue. Let me say the point under discussion is 2. So I will say the scale factor is 1/2. And if we move from black to red, I can say the scale factor is 2. Number more than 1 would mean the graph is expanding, opening up, stretching out. Number less than 1 would mean it is squeezing in. Okay, let me use these letters. A, B, and C. This is A to B. This is A to C. Does it make sense? From A to B, scale factor is half. From A to C, scale factor is 2. Yeah, Muhammad,
Yes,
Mahad,
understand.
So I said I understand.
that's good. Okay.
Yeah.
Now this, whatever this is, it has to do with A. For example, y is equals to x square. I can say the graph of y is equals to x square would look like this. A new graph, y is equals to 2x square will look like this. Do you agree?
Yes.
Just to make our concept concrete, let's discuss few values. X is equals to -2, -1, 0, 1, 2. And for the first one where y is equals to x square, and for the second one where y is equals to 2x square. So let's say for this first one, -2 square is 4, 1, 0, 1, and 4. If I have to plot this at 1, it is 1. At 2, it is 4. But for 2x square, at 0, it is 0. At 1, it is 2. And at 2, it is 8. So for the same values, 2 squared is 4, 4 2 times is 8. This was 4, but now the new value is 8. So that is how it squeezes in. So for this transformation, A to B, I can say it is a stretch of scale factor 1/2. Where is this 2 coming from? You can see it for yourself. Y is equals to 2x square. This is where this 1/2 is coming from. If we introduce a new equation and say y is equals to 1/3x square, this is how the curve will look like. And I can say, let me name it C. From A to C. And remember, it is always a stretch, whatever the scale factor is. It is a stretch of scale factor 3. Does it make sense? And
Yes.
we will not have two transformations in one single part. That is A, H, and K all three at the same time. It is not in the syllabus. So either we are discussing scale factor or we are discussing the translation. So let's have a little visual of this, or we can say a little fun. If you have this installed, you can definitely try a few questions and see how the graph changes. We started with the linear equations. Y is equals to 2x. This is the graph. Second, y is equals to 2x. I'm going for 3. 2x plus 3. So y is equal to 2x is already there. What happens when I enter 3? This is the result. And what if I go for a negative number? Y is equals to 2x minus 1. This is the result. What happens if I change the gradient? First line was y is equals to 2x. I'm trying y is equals to 3x. So y is equals to 3x. Fourth line. Coming to curves, y equals to 2 bracket, let's try x minus 2 squared and plus 1. Okay, it has simplified this equation. Let's discuss this before. I didn't know about the limitation of the software. Before moving ahead, let's discuss this. This is the equation which we used. Y is equals to 2 into x minus 2 whole square plus 2. And the software simplified it to y equals 2x square minus 8x plus 9. Whatever the numbers are, we can always change it to completing square form. But see for yourself, the coefficient of x is negative, right? Negative coefficient will move it to right hand side. Because whenever we go for completing square, what do? We close a bracket, write x and copy this sign over here, negative sign. And whatever the number is, the number will be 2. This is 2 plus 1. And the next step is half of coefficient of x, which would be plus 2 square minus 2 square. And solving these, so we get this as our completing square form. So negative number with the coefficient of x means the graph will move to right hand side. And positive number in y-axis definitely means the graph is moving upwards. So you can compare these two, but the demand of question is always satisfied after completing it into completing square form, which we just did. Okay. So further comparing this, this is the previous equation. Can you see this equation in left-hand corner, bottom? Y is equals to x minus 2 whole square plus 1. So from minus 2, I'm changing it to minus 3. Where should the equation go when I change it from minus to minus 3?
It'll move right.
It will move right. This is your new graph. So what happens when I change this 1 with 3? I'm copying the first equation again and again. What happens when I change this 1 to 3? The graph moves upwards. And for this 2, I've mentioned it as A. Where did you go? This is A. Oh, I need to have a variable. Slider. Okay, let me remove the previous graphs. Okay, when we have this equation y is equals to x square, that means a is 1. If I increase the value of a, see what happens. Can you see? The graph is squeezing in. What happens when I decrease the value of a? Taking it to 1 again, making it y is equals to x square, decreasing it further. See, you see the graph stretching? And obviously with a negative sign, it is a sad face, and all other concepts remains same. And animation. So this is it. X square, the value is increasing, the graph is squeezing in. The value is decreasing, graph is stretching out. So whatever the value of a is, a reverse of that is the scale factor. A reverse of that. For example, main equation y is equals to 1x square. New equation y is equals to 2x square. So scale factor is 1/2. New equation y is equals to 3x square. Scale factor is 1/3. New equation y is equals to 1/4x square. So scale factor is 4. Reciprocal of a. Scale factor is 1/a for any comparison. This to this, this to this, and this to this. Is it clear?
I understand.
Yes, sir.
Okay, now let's have a look at the book.
We didn't learn about it in class, but it was highlighted in the IGCSE revision guide for math. And it
It
came
is-
up in the exams.
That happened in GCE as well since the last 2 years. It is not even in their syllabus. They didn't do it in class. It is not there in their syllabus, but since 2020, they're having questions regarding translation. So that is why we covered this concept. And here, right in your book, this is graphs and transformations. You see, chapter 4. It is there now. So sketching of cubic graphs, we did with like squared graphs. And let's have a look at the cubic graphs as well. So if you see x minus 2 whole cube, the turning point is 2. So from -2 to -3, it has the same effects. The only change is that one part of the curve is upwards, the other part is downwards. So these are few examples for quadratic and cubic. So you will be practicing these with GeoGebra first. You'll make your observation strong by just looking at the equation. You should know how it would look like. If you see this question number 3b, have a look at this. If it would have been y is equals to x cube only, y is equals to x cube, the graph would look like this. So when you add anything to it, 5x square, whatever the value of x is, positive, negative, anything, the answer will be positive all the time. So the graph will move upwards. With this 4x, it has an effect to move it towards left and right hand side. Let's see. X cube plus 5x square plus 4x. Y is equals to x cube plus 5 raises it, but 5 x, and then it is still a curve. It is still a curve. 5x square y is equals to x cube plus 5x square. And I needed to copy that. X cube plus 5x square plus 4x. This is how your graph looks like. Here is the complete look of that. So see, when it was x cube, it is simply passing through the origin. When it is plus 5x square, there is an effect of x square. The graph moves upwards. The graph moves upwards, and adding plus 4, the graph shifted it slightly towards left. If you compare these turning points, first it was at 0, 0. Now it is at negative x and negative y. So for comparison sake, it's better if you will draw these, if you factorize each of the following and then sketch, it will take, like, you may be practicing 2 or 3 questions in an hour. But using this software, you can compare 20 to 30 questions within 15 minutes. Any questions?
No, sir.
One, let me do it with you. One question. This is x cube plus x square minus 2x. If I take out x as common, I'm left with x square plus x minus 2, right? So I'm factorizing it. So x into x square plus 2x minus x minus 2. Taking out x common, this is x plus 2, minus 1 common, this is x plus 2. So I'm left with x times x minus 1 times x plus 2. So I can write this equation as this. When it is equal to 0, I know that first value of x will be 0, second will be positive 1, and third will be negative 2. So this will intersect at 0, positive 1, and negative 2. So there are only 2 ways this graph could go. One is this way. The other is this way. Which one is correct, red or green? Any guesses? Red or green? Which one is correct?
Red.
Yes, red is correct. If you look at x cube only, the graph is like this. Adding x square, it moves the graph upwards and makes the traits of x square visible. And then subtracting something, it moves it to right. This positive x cube actually defines this shape. If it would have been negative x cube, the shape will look like this. Positive and negative. So this was positive, so red is correct and green is incorrect. Look at this one, negative x cube, and it intersects at 2. So this is your point 2, and the graph would look like this. Sorry, there's one extra curve. There are only 2 curves in the cubic graph. Like this. A negative reverses it in vertical direction. So this is chapter 4. Start with 4a, or even start with the solved examples. And do practice them. The more you solve them, the more you'll understand. Any question for today? Thank you so much for joining. See you tomorrow, inshallah.
I have one question.
Yes.
Tomorrow, are we going to cover x and x squared reciprocal graphs, or is that not part of our syllabus?
Which one?
X reciprocal and x squared reciprocal graphs,
That is in
or is it?
IGCSE. That is basic. You should have already known y is equals to x is this. Y is equals to 1 over x if we consider only positive is this, and negative 2 results like this. Compare this with y is equals to x square. The sketch is this. This was in O levels. And y is equals to 1 over x square, reciprocal graph. It is this. Wherever you see the curve not touching the x-axis or y-axis are asymptotes. Okay. Y is equals to x cube is this. And y is equals to negative x cube is this. This was in O levels. And definitely the answer is yes. We should know how they look like. If you've forgotten them, yes, you should recall them, revise them.